Hi everyone, this is R. Parthasarathi. I am working as an assistant professor in the Department of Civil Engineering. So now we discuss about liquefaction. This presentation is from Structural Dynamics and Earthquake Engineering. Let's move. So a liquefaction of soil. A liquefaction is a phenomenon in which the strength and stiffness of soil is reduced by earthquake, shaking, or in order to rapid loading conditions. So the pore water pressure may become so high that many of soil particles lose contact with each other. In such cases, the soil will have very little strength and will behave more to liquid than solid. So when liquefaction occurs, the strength of the soil decreases and ability to soil deposit to support foundation for buildings and bridges is reduced. So a liquefaction of soil is also exert a higher pressure on retaining walls, which can cause them tilt or slide. So the movement can cause the settlement of retained soil and distortion of the structures in the ground surfaces. So increasing the water pressure along trigger landslides and causes collapse of the dam structure. So this is a small example video for liquefaction of soil. So yeah, underwaters are abrated due to the effect of shaking caused by the ground shaking. Then only this kind of liquefaction is occurred in any of the ground levels. This is a example of fault, like it's ground shaking. That's all. So, liquefaction is a flow of liquefaction. The types is a flow. A liquid is going to have a flow. Is a phenomenon which the static of equilibrium is destroyed by the static for dynamic load soil conditions with the residual strength, and its static shear stresses to the soil exceed the shear strength of liquid soil. This will causes of a large deformation in the soil structures, and also one of the causes of earthquakes, blasting, and the pile driving are the example of dynamic load conditions. On the trigger, the strength of the soil susceptible to flow liquefaction no longer. So types of liquefaction is a cyclic of mobility. So this is the liquefaction phenomenon triggered by the cyclic of loading condition occurring on the soil deposit with a static of shear stress lower than the soil strength. The deformation due to cyclic mobility develop of incrementally because of static and dynamic of the stresses. It's a lateral spreading, a common result of a cyclic mobility. So this is some effect of loss bearing the strength. So in effect, number one, the grounds can liquidly and lose its ability to support the structures. Lateral spreading, the ground can slide down very gentle slopes as shown in figure in upcoming towards that stress streams bank riding of buryl liquid layer. So mainly caused by the cyclic of mobility and the building structures, pipeline, railways, etc. The foundation settlements could be caused. So this is the effect of liquefaction soil and road conditions and normal ground surfaces also liquefaction effects are occurred. So the sand boils is that sand laden water can be rejected from the purified or buried liquid layer and erupt the surface to form and sand volcans. So there's some a few examples of ground shaking with the different layers of uh, levels of grounds during the earthquake conditions. Ground settles or move to water pressure increasing. So this is that example for bowls. So the next one is a ground oscillation. So flow failures. The earth moving to steep slope with a large displacement and much internal disruption of the material. It causes by the flow of liquefactions. So this kind of effect, flat ground, liquefied sediment starts to slosh into the wave as shaking continues. So a cracks on the ground open and close, the water may erupt from them. So a flotation is a light structure that and purite the ground can float onto the surfaces when they are surrounded by the liquefied soil. So some settlements are affected in the liquefied soil, reconsolidate flowing and earthquake. So the ground surfaces may settle and subside, the shaking decreases, underlying become more. So flow failure, the best example for flow failure. Thank you. Thanks for watching this video.